Okay. So this is the question. So do you think you can find? May I know from yesterday that we learned which formula involve margin of error? Which formula got n in there? Sample size. We have this formula, correct? You can have this formula. Z alpha over 2, that is the standard score. Then standard deviation of the population. Divide by square root of n, correct? We have one of this formula. Yeah. We also have this formula that is called margin of error. Which is okay. Now, in these two formulas, okay, now you have to get information. This one, we have this, no problem. We have this. Standard deviation of the population we know is 16.5. All right? Okay, now you tell Ms. Do how to get. So now, another issue is, do we know this? The Z score, or yesterday I put it as K. Can you find this? Because if you want to find n, listen here, if you want to find n, correct, using this formula, you must have this, and you must have this, and you must have this. So now, this problem is solved. How about Z alpha over 2? That is the standard score. Can we solve the standard score? Can we solve the standard score? Okay, I will go by alphabetical order. Adriana, can we solve the standard score, Adriana? Yes. How to solve the standard score? Adriana, please give me some idea. Yeah, who don't know use calculator? If you say use calculator, then you have to tell me how to use the calculator. It's no point you just tell me use calculator, Adriana. That doesn't solve the problem. How to use the calculator to get the answer? I want the way to do it. Who don't know use calculator? How to do it? I ask you lah. If you as a student, you ask your teacher, hey, how to find this? Your teacher reply you as using calculator. You like it or not? So Adriana, tell me how to get Z alpha over 2. Don't give me the answer, use calculator, okay? Yeah, inverse norm. Thank you. So when you put inverse norm, how should you put it? Depend on your calculator, correct? You use inverse norm. Okay. One of the calculator that we can use is you can use, actually there are a few ways to use it. Okay, so 0.92, 0, 1, then center. They will have two numbers come out. You just take the positive part. So what is the answer? Adriana, can you tell me the answer? Hmm? 1.7. Adriana, I want Adriana to give me the answer. If I don't call you now, exam only I call you, then we'll be in trouble. Adriana, is it 1.75 plus? Okay, so that is also done. Okay, so this problem is solved. So now, how to get margin of error? So now this problem is solved. This problem is solved. So now, how to get margin of error? Okay, how to get margin of error from this one, the one I put 2 tick. Okay, good. Someone have given me, Cindy. Cindy, pay attention, scared already. Okay, so you know that margin of error is half of the width of confidence interval, correct? So the width of the confidence interval is the highest minus the lowest. Then divide by 2. Okay, so you get your margin of error. Now can you find the sample size? Can you find the sample size? Yeah, you use the formula, you can get the sample size. Am I right? Okay, so you have 153.7 minus 148.3, and then divide by 2. So your margin of error is 2.7. So I put into the formula 2.7 equal to 1.75 times standard deviation is 16.5 over square root of n. So therefore, my square root of n equal to 1.75 times 16.5 divided by 2.7. Then my n is equal to 1.75 times 16.5 divided by 2.7, the whole thing squared. Hello? Can Anna? So is 114.37. Okay, so therefore n must be 115. Remember, always round up. Because n must be a whole number, we must always round up. The reason is, if your sample size is smaller, the confidence interval width will be bigger. So if I take 114, it will be out of this range. You get me? So always round up. Always round up. Are you clear? So now from here, can you create a formula? Can you create a formula for sample size? Can you create a formula for sample size? Write sample size as a subject. Okay, so n equal to, we go back to here. What is this? This is your standard score based on the confidence level, right? This is the standard deviation of the population, correct? And this is the margin of error, am I right? Okay. Got it? So, look, so I can write my sample size is equal to Z alpha over 2 times by standard deviation of the over margin of error square, right? Or if I don't want, can I also write like that? If I write like that, you see whether am I right or not? Correct or not? Can I also do like that? Yes, I also can do like that. So this is the formula you rearrange from there. So if you have this formula, then it will make your life much easier. So you don't have to go and find this, you don't have to rearrange yourself. So you can straight away put into this formula and use it. Are you clear? So is this formula important? The answer is a yes. So, hello? So important, correct? This formula. Okay, so can I? So for this confidence interval for true population mean, our parameter is the population mean, okay, that we want to study about. Hello? So you have to write down the formula. Okay. I will try one question from exercise 9D.2. Okay, 9D.2. Wait, I want to. Okay, I don't want. If the size of n all is given with. So if all is given with, you can just key in. Okay, now as I give you a question that is not talking about with. Okay, 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 this one I have to create the question because your exercise here don't have that question. Okay, find the minimum sample size so that the margin of error is within the question are within 0.5 gram. Okay, given the standard deviation Hold on, of the population okay, 0.5 gram is too small. Sorry. Find the minimum sample size so that the margin of error is within 1.5 gram at the confidence level of 90. Okay. Given that the standard deviation of the population is 2 gram. Okay. No. Okay. 2 gram. Okay, 12 gram. Okay, 12 gram. Okay. So now how are we going to do this? Okay. So the confidence level is 95%. So we have this formula. So when I say the margin of error is within, so it cannot go more than that. So that means within. So that means it's 1.5 here, 1.5 here. Must be inside, right? So you can either use this formula or if you use the width, then you have to double it. If you use this formula, then you have to double this value. So you have to be very careful. They say within, then you better. They say margin of error within this. So you put 1.5. So sometimes they don't say margin of error. They just say the error of within 1.5. So that means plus or minus 1.5. Are you clear? So that means that refers to margin of error. So we use this formula. Our n will be equal to, okay, may I know what is my Z alpha over 2 if 90%? This one you should record down in your one-page handwritten note because 95, 90, and the one is a very common 1.64. Okay, 1.65. Okay, we put here 1.65. Standard deviation is 12 over, and the margin of error is 1.5. Then you square it. Okay, may I know what is the answer? Okay, 174.24. So therefore, the sample size, always write down this, must be at least means the minimum, 175. Are you okay? Can or not? Okay. Done, huh? Okay, so we are going to continue with 9 point, okay. There is 9D.3, using a confidence interval to test a claim. Okay, can you please look at example 9? Okay, they say the volume of the milk dispenser into a carton by a machine is normally distributed with a mean which can be adjusted. Okay, like the machine we are talking about, and standard deviation of 10 ml, which is fixed. Okay, the value of the mean is supposed to be 1005 ml. The quality controller tests 25 cartons. Find that this mean volume is 1002 ml. Okay, so now every time when you see a problem, you should train yourself to know what is the population. Can you tell me what is the population? Population is what? Hello? Okay. You want me to call the name? Ken? Almahan?
Yes. Can you hear me, miss?
Can you tell me what is a population in this example 9?
Is it the milk dispensed into the cartons by the machine?
Yes. So the population is the milk carton produced by the machine. By a machine, huh? Okay, good. So what is the parameter of our interest? Parameter of interest is volume of the milk in the carton. Okay, good. Is it the volume of milk or the mean volume of milk? Your parameter of interest, is it the volume or the mean volume? You're right, mean volume. Mean volume of milk in the cartons that is produced by this machine. Okay, good. So what is our point estimator? So now, okay, so now for this case, can I assume that the sampling distribution for this case is the sampling distribution of the mean volume of milk in the cartons normally distributed? Why? Okay. Because it's not normally distributed, you cannot use our way, correct? Because we assume it is normally distributed. Okay, Ashley, is the sampling distribution of the mean volume of milk in cartons, milk in the cartons normally distributed? Why? Answer, Ashley?
Normally distributed.
Yes. Okay, why?
Because it's stated in the question.
Yame, the question state the volume of milk in dispensed into the carton by a machine is normally distributed. It didn't say the sampling distribution.
Oh.
You cannot say it's stated by the question. The answer yes is correct, but the reason you give is wrong. So if I give this 2 mark correct, you get 0 mark also, because the reason that you give is wrong. Every time when you come to this question, you should look for the powerful theorem. What is that powerful theorem? Ashley?
Central limit theorem.
Yeah, so you have to write yes, because according to central limit theorem. Okay, you continue. Ashley? So you see, I told you that theorem is very important. You write down or not? You don't, you have a very bad habit. You wait when exam come only, I want to prepare my one-page handwritten notes. Every lesson, when I tell you that the formula is important, the theorem is important, correct? You better quickly write down in your one-page handwritten notes already. Ashley, please. You have your notes with you, you go and search. If I'm teaching physically, I tell you, I practically force you to bring all your notes. Yeah, I know someone is trying to explain.
Yes, because
Faster.
according to central limit theorem, if population is normally distributed, any sample will be normally distributed.
Any sampling distribution will be normally distributed regardless of the sample size. Okay, so because according to central limit theorem, the population of volume of milk in cartons, volume of cartons of milk. Okay. The population of volumes is normally distributed. So therefore, the sampling distribution or mean volume of milk in the cartons will be normally distributed. Regardless of the sample size. Okay, got it? So these are the things. Every time when you see, you have to keep reminding yourself like that. So when you write your report, you will know what to do. Okay, part A. Construct a 95% confidence interval. And if I ask you to interpret, you have to write in words. We are 95% confidence that. Okay, please construct using your calculator. Okay, you all know how to get the answer. I don't have to explain. Okay, so when I say interpret, you have to write in word. You have to write, we are 95% confidence that, okay, the true population. What they want you to find? Mean volume. Okay, dispensed by the machine. Can be as low as, I try not to say within, okay? That is my habit. You can say within, it doesn't matter. Can be as low as 998.1 ml and go as high as 1005.9 ml. Okay, so now they say, use the 95% confidence interval to assess the claim. That means find that their mean volume. Okay, so the claim is supposed to be, so is it less? Okay, you see how I justified the claim. I don't use, like say within, okay, it said 1005 ml lie within 95% confidence interval. So despite the fact that the sample mean is less than 105, we do not have enough evidence to reject. So when you talk about evidence, I'm talking about this sample doesn't allow me to reject, but that doesn't mean this is true. That's why we do not have enough evidence to reject the claim that the mean is 1005. That means you don't reject. But you cannot use the word, your textbook use the word, because this is not 100% true. It's just that this evidence says you don't reject. Hello? Do you get me? So we will say the highest possible predicted true population mean is 1005.9. So that means 1005 ml is possible to happen. So we do not have enough evidence to reject the claim that say the mean is 1005 ml. You get me? Hello? You have to use, we do not have enough evidence. That means this evidence doesn't allow us to reject. But I cannot say it is true. You get me? Okay or not? So it's based on this example. Okay, now let's try one of the question in 9D.3. Okay, which question you want to try? Okay, let's try question. Actually, we should try all the questions. Okay, you try question 1 first. We do this afterward, the next lesson we do the rest. Okay, 9D.3, question 1. Okay, question 1. So I'm not going to repeat what is the population and so on. This one, it doesn't say anything, okay? So every time when you read a question, the claim is the population mean is 50. Okay, standard deviation is 7. sample size is sample mean is 49.1. What is the sample size? Huh? Did they say? Oh, 60. Okay. So you go to your calculator, Z interval. Go to stack, test, number 7. Z interval. So key in stack. Input is stack. Standard deviation is 7. Sample mean is 49.1. Sample size is 60. Okay. Is there a confidence interval given? Yeah. Confidence level, yes, 95. Yeah. So you got this. Since they didn't tell us what is the what mean of what we don't know. So we have 47.329 and this is 50.87. So if according to your book, they just round accordingly. So if you round accordingly for this case, I will not deduct your mark also. So can someone give me in words? We are, so you have to write down in words. Huh? Okay, can someone read it in words? Put it, interpret in words. Okay, Brandon, we are?
We are confident that 95% confident that the true population mean
Yeah.
is within 47.329 and 50.87.
Yeah, okay. Now, so use the 95% confidence interval to access the claim. So is the claim justified? So you say we have no sufficient evidence to reject the claim because, yeah, the mean of 50 is possible to happen. Correct? Okay, now, listen. I'm going to make a different claim. So this is my claim. Look, if someone claim, the claim is like that. The population mean is at least 49. So now, how are you going to use this confidence interval to justify this claim? I want to see how my student justify. Okay, so the next person. Okay, how to justify? Okay, Jian. It just happened you are the next one, okay? Okay, Jian, how to justify this claim using this confidence interval?
There is sufficient evidence to accept that the population...
Cannot use the word accept, please. Either sufficient evidence to reject or insufficient evidence to reject. If you say insufficient evidence to reject, that means you say that is right. Inverted comma, it's not 100% right. It's the evidence say that it is right. Okay.
There is insufficient evidence to reject this claim as it is in between the confidence interval.
Look, my claim is the confidence interval is this. The confidence interval, if I draw, it can be this value now. And it can be this highest, it can go this now. So one of them is possible, you know or not? So I want it to be 49 and above. So I have to look at this. So that's why I say all these, whatever inside the confidence interval, I will take it as the possible value of population mean. But I don't know which one will happen, but I know it can be here and there. So there is a meaning of confidence interval. You get it, what I mean? So that's why I say I'm 95% confidence that, that's why I like to use the word, I don't want to say within. They say, I have 95% confidence that the true population mean what? This case, they didn't give us whatever. Mean can go as low as, that's why I prefer to write in this form, and as high as that means all the value between here is possible to happen. That is the meaning of confidence interval. So if I claim, my claim is that the population mean is at least 49, then cannot. What happens if the population mean is here? This is my predicted, this is my estimated. So that's why I say possible value. I don't know which one can happen. So I know it will happen here. So if you want to justify this claim of at least, so you have to look at the lowest possible. So, are you okay? So Jian, you like to re-justify the claim?
There is sufficient evidence to reject this claim as the lowest possible value is 47.329,
Which is?
which is the
Which
true
is?
population mean.
Which is less than 49. Am I right? Because my reference is here. I say at least 49 means it must be greater than 49. Am I right?
Yes.
So I have sufficient evidence to reject the claim because the lowest possible predicted population mean can be as low as 47.3, which is less than 49. See or not? Are you okay? You write down the way to write the justification. I'm going to call another one to read the justification for this. Okay, after Qi En is Cindy. Cindy Wong. Read.
Because we do not have sufficient evidence to reject it as it is lower than 49.
Insufficient evidence to reject. That means if you say insufficient evidence to reject, that means this is correct now.
sufficient
That means-
evidence to reject.
We have sufficient evidence to reject the claim that say that the mean population is at least 49 is because the lowest possible predicted population mean is 47.3, which is less than 49. Okay? So now you have to look at the claim. So don't just keep saying within. Like the book that one, I will not say within. I will just say mean 50 is within the confidence interval. I will say we have insufficient evidence to reject the claim because mean of 50 is possible to happen. Because the confidence interval, the highest is 50.8 and the lowest is 47.3. I put it like that. So that give myself a very good understanding of what you mean by confidence interval. That means you are using a sample mean to make a prediction of the, or if you want to put prediction, you can say to make an estimation of all the possible population mean. So it lies within the interval. Are you okay? That can happen. So my population mean can be 47.3, it can be 50.8. So from here, I can ask a lot of other questions. I can ask you about probability. Okay? We will talk about the question as we go on. I will try to introduce some other things. So everyone, are you okay? So your claim, how you make your claim is very important. Okay? Okay, let's look at number 2. Yeah, let's look at number 2. I try to teach you something from question to question, okay? Number 2. Depend on the suitability of the question, okay? Depend on my idea also. Okay. Any of your parents have the production of food? Huh? Any? The factory? Then you can write a report according to this one, then you can go and collect the sample. You can ask your dad's worker or whatsoever, or any one of your dads are working in a factory or packaging or whatsoever, then you can do. You can write a report on that. So you say the net weight, net weight, that means the mean weight, okay? 100 grams. So the standard deviation is 1.6 grams. Okay, that is very low. Okay, you see the customer lighter than the recent purchase. So the factory quality control manager decided to investigate. He sampled 40 bags and find that their mean weight is, okay, so the sample mean that you are going to use to find the confidence interval is 99.4 grams. Yeah, the sample size is 40. Okay. So what is the parameter of interest? The mean weight of a bags of nuts produced by this company, correct? By this manufacturer. So the population is all the bags of salted cashew nut produced by this company. Yeah. Okay. So construct the 95% confidence interval. Okay, construct ready. Z interval number 7. Standard deviation is 1.6. Mean is 99.4. Samples is 40. Confidence level is 95. Okay, done. Okay, so can someone justify the claim? So we are 95% confident that the true mean weight of bags of salted cashew nut produced by this company can go as low as 98.9 gram and as high as 99.9 gram, right? Okay, so that is your interpretation. So B, use the confidence interval to test the claim that the mean net weight of the bag is 100 gram. By the way, you see the claim of the customer. A customer claimed that the bags have been lighter in recent purchase. Lighter. Lighter, that means the mean weight is less than 100 gram. So how are you going to justify the claim? So next person, EJ.
There is sufficient evidence to reject the claim mean net weight of 100 grams because the highest possible predicted mean net weight is 99.9, which is less than 100 grams.
Thank you. Perfect. You see, your understanding of the confidence interval is very important. So we have sufficient evidence. No. We have insufficient evidence to reject the claim of the customer that say that the bags has been lighter than in the recent purchase because the highest possible mean, predicted mean is 99.8, which is less than 100 gram. I'm talking about the customer. But if you are talking about B, then we have sufficient evidence to reject. If you're talking about the claim of the customer, that means we say we have insufficient evidence to reject the claim of the customers that say that the bags has been lighter in a recent purchase because the highest possible predicted mean is 99.8, which is less than the 100 gram promised by the company. Okay, so it depends on, if you are talking about B, use the confidence interval to test the claim that the mean net weight of bag is 100 gram. So we have sufficient evidence to reject the claim that the mean weight is 100 grams. But if we are talking about the claim of the customer, then we have insufficient evidence to reject the claim of the customer. Are you clear? Okay, Anat? Okay, so we will continue with the rest afterward during the next lesson. Yep. Okay, thank you, class.
Thank you, Matt.
Yeah.
Thank you, Miss.
Thank you, Miss.